We have a worker that lifts a 50-kilogram crate from the ground to a platform. So there's a crate, some worker guy, and he's going to lift it up. The platform is 4 meters high, and he's going to use a rope and pulley system. The worker applies a constant force of 550 newtons, and we need to calculate the work done by the worker, the gravitational potential energy of the crate at the top, and determine if the applied force did any work beyond lifting the crate. So we have the mass of the crate is 50 kilograms. We have that the height of the platform is 4 meters. We know there is an applied force of 550 newtons, and we want to find the work done by the worker. We want to find the gravitational potential energy at 4 meters, and we want to determine if there was any extra work done. So this is a work problem. We have work is equal to force times our change in position, cosine of theta, and we also are being asked for potential energy, since this is only gravity. Gravitational potential energy is going to be dependent upon the location of an object. So I'm first going to start solving this by looking for work. I'm going to put a box around W so that I remember that that's what I'm solving for. Work is equal to force times my change in position, cosine of theta. It's important to remember that our theta is determined by the direction that the force is being applied. Since this is tension, the force is going to be going upwards, and also the direction that our object is going to be moving. Since our object is being lifted, it's going upwards. The angle between these two is 0 degrees. Cosine of 0 is 1. So we can simplify our work equation as force times our change in position. This means that our work is going to be 550 times 4, and we get 2,200 joules as our solution. The next thing it asks us to figure out is what is the potential energy at the top. So our potential energy for gravity is mgy, where y is the location of the object at that point in time. Since it's only asking us for the potential energy at the top, we are just going to plug in the mass of our crate, which was 50 kilograms, g, which is 9.81, and the position of the object at the top. So y will be equal to 4. This is going to give us a potential energy of 1,960 joules. Now we know from the conservation of energy that our work should be equal to a negative change in potential energy, but we see here that our work is 2,200, and this is not equal to 1,960. So where did this extra energy go, right? So we lost 240 joules. Where did it go? Most likely, it went to acceleration of the box. It could have been lost to friction in the pulley. And because we have an applied force, we don't want to use work is equal to negative change in potential energy. I have another video that discusses why we do not want to use this. It's not applicable for applied forces.